Mm, Introduction to DC circuits. Today we'll discuss a topic called electrical current, electrical voltage or potential difference. First we'll go for definition. The flow of free electrons through a conducting material is called electric current. Is called electric current. Now we'll go for a formula called A constant current is equal to charge by time. Now we'll get one more thing called instantaneous current. I of t is equal to change in charge by change in time. And comes to unit, it is measured in amperes. Abbreviation, electric current is always denoted by small I of t or I. Ammeter is always connected in series with the resistance. Ammeter is nothing but it measures current. Two types of currents we have. One is called a DC current. A DC current is a current that remains constant with time. Second one, alternating current is a current that varies with time. You can see the graphs, the difference between a DC current and a alternating current. Alternating current. And this is what about current. Now come to electrical voltage. The definition of electrical voltage is the potential difference is the energy required to move 1 coulomb of charge from one point to other. We have to give a supply to the conductor so that electrons will move from one place to other place in the conductor to do useful work. To do useful work. So the potential difference is nothing but a one should be higher potential, other should be lower potential. So that electrons will flow from lower potential to higher potential. Yes, come to the formula. Constant voltage, capital V is equal to work by charge. Capital V is equal to work by charge. Work by charge. And V is equal to instantaneous voltage. V is equal to change in work by change in charge. So it is the units for W energy is joules, charge for coulombs. The voltage is volt. It is measured in volt. And it is denoted by capital V or V of t. Always voltmeter is connected in series with in parallel with the resistance. Always voltmeter is connected in parallel with the resistance. What is voltmeter? It voltmeter is nothing but it measures voltage. It measures voltage. It measures voltage. Clear? Right. Now we'll go for the other topic called power and energy. Power and energy. Right. Electrical power. The rate at which work is done. The rate at which work is done. Right. What is electrical power? The rate at which work is done in electrical circuit is called electrical power. The formulas will be three formulas for constant power. Power is equal to work by time. Power is equal to voltage into charge by time. Since from V is equal to work by charge, we can apply this formula in P is equal to work by time, so that we get P is equal to VQ by T. Now I want to convert into voltage into current. Still have to make some calculation part. P is equal to V into Q by T, where Q by T is nothing but a current. So finally we get P is equal to VA watts. P is equal to VA watts. It is nothing but a equation 1 for DA. Then what will be the second formula? P is equal to I into R into I. From since Ohm's law, V is equal to IR. Now we'll get second formula, P is equal to I square R watts. P is equal to I square R watts. The third one, P is equal to V into V by R. It is also from Ohm's law, V is equal to IR. So finally we get one more formula called P is equal to V square by R watts. Totally we have three formulas for power. P is equal to VI watts, P is equal to I square watts, P is equal to V square by R watts. Now we will go for the instantaneous power. It is nothing but a change in work by change in time. Where is in power in watts. Always power is measured in watts. The electrical power is denoted by P of T or capital P. P of T or capital P. These are the different kind of formulas related to electrical power. Now we'll go for electrical energy. The definition of electrical energy will be energy is the capacity to do work in electrical circuit. It is the capacity to do work in electrical circuit. The formula for constant energy will be the first formula, energy is equal to power into time. Power into time. Energy is equal to what is P? Voltage into current into time. Voltage into current. What is P? Voltage into current into time. The third formula will be we have to substitute V IR Ohm's law. I into R into I into T is equal to I square RT. The third formula, fourth formula will be E is equal to V square by R into T. These are the four formulas related to energy. You have to remember these kind of formulas to solve the small simple problems in electrical circuits. And these are the basic formulas in electrical circuits. And the unit for energy will be joules. It is always be represented or denoted by letter capital E, in some textbooks capital W. So these are the four terms we have to learn in electrical circuits, the basic terms. Always remember that the basic terms are current, voltage, power, energy. Power, energy. Power, energy. So once again I want to revise the topics called current, voltage, power, energy. You have to remember the formulas first. Okay, these are the formulas. So what will be the formulas? Formulas always you have to remember are current is equal to Q by T. Very important formula. Second, voltage is equal to work by charge. And third one, power is equal to VI. Power is equal to I square R. Power is equal to V square by R. And fourth formula, energy is equal to power into time. Energy is equal to V into I into T. Energy is equal to I square R T. Energy is equal to V square by R. V square by R into T. And always remember that ammeter is always connected in series with the ammeter is always in series with the resistance. And always remember that voltmeter is always connected in parallel with the resistance. Parallel with the resistance. So these are the basic terms related to electrical circuits. It's not in electrical circuits, electrical machines, electrical engineering, whatever it may be. Wherever you go, these are the basic terms you have to remember the formulas and the definitions. Right. Right. We'll go for another topic called today's topic called the basic. We'll go for the topic, right? Topic are the definitions. The second topic. We'll go for the second topic. Right. The second topic will be basic components of electrical circuits. We call it as resistance, inductance, and capacitance. There are three basic components, passive elements of electrical circuits. We call it as the passive elements. We call it as the passive elements. They are resistance, inductance, capacitance. What is resistance? Definition. It is the property of a conductor which opposes the flow of current through the conductor is known as resistance. Is known as resistance. It is represented by the symbol. This is called a symbol. It is represented by the symbol. This is called a symbol. The resistance is measured in ohms always. It is denoted by capital R, small r. Here we have to remember that conductance. What definition of conductance? The reciprocal of the resistance is known as conductance. The reciprocal of resistance is known as conductance. G is equal to 1 by R. G is equal to 1 by R. Reciprocal of resistance is known as conductance. And we call it as sigma is equal to conductivity or specific conductance. The units for conductance is Siemens or mho or mho. Abbreviation it is denoted by capital G. It is denoted by capital G. It is denoted by capital G. So these are the different kind of definition, unit, abbreviation. symbol for resistance. And we have studied about the conductance also. It is nothing but a reciprocal of resistance is known as conductance capital G is equal to 1 by R. And the units are mho or Siemens. Always represented by capital G. Capital G. Capital G. If I go for inductance, if I go for inductance, it is the property of a coil which opposes change in current flowing through the coil. It is the property of a coil which opposes change in current flowing through the coil. And now I go for this is called symbol. Symbol. We call it a symbol. This is called a symbol. Now unit will be Henry. The index is measured in Henry. And abbreviation is denoted by capital L. Capital L. A small l. Now come to capacitance. It is the property of a material which opposes change in voltage across the material. It is the property of a material which opposes change in voltage across the material. And now this is called symbol. We represent this as symbol. This is symbol. The capacitance is measured in farad. It is denoted by capital C or small c. Capital C or small c. Now we have completed the topic called resistance, inductance, capacitance. Now this is called a basic components for electrical circuits. Resistance, inductance, capacitance. We call it as the passive elements also. Passive elements also. These are the basic elements. Always remember in electrical circuits, we always listen about these resistance, inductance, capacitance called the passive elements. So we should know the definitions and formulas related to resistance, inductance, capacitance. Components. We call it as the components or simply called as elements. Element is the best word. Element is the best word. Right.